Hello, my name is Moon Sung-hyun. Today, I would like to introduce a case in which I considered the possible use of CNN technology in wildlife management. First, let me briefly explain what CNN is. CNN is the convolutional neural network. Don't be afraid, it is just a fancy AI tool for analyzing images. Unfortunately, as far as I know, it has nothing to do with a broadcasting company. The actual mechanism behind CNS is deeply related to mathematics, and that is one of the reasons why I became interested in this technology. When I was studying mathematics, one of my friends was also deeply interested in CNS. I talked with him quite a lot about how CNS work, and that was my first real exposure to this technology. Later, this memory helped me connect my experience at wildlife workshop with the possible use of CNNs. Now, let me explain how CNN work and why they are such a fancy AI tool. CNN is a technology that extracts useful features from images. Because of this, CNNs are widely used in areas such as facial recognition and autonomous driving. For example, a CNN can help determine whether the person in one photo and the person in another photo are the same individual. It can also help classify whether an object in an image is a person or a car or an animal or something else. To make this easier to understand, let me imagine a situation where we look at the cat and try to identify its breed. As human, we widely look at visual features such as fur color, facial shape, or body size, or overall experience. A CNN can also use these intuitive visual features. However, what I found especially interesting is though repeated deep learning, CNN can also detect subtle patterns that human may not consciously recognize. In other words, CNN can also use not only visual characteristic that human can easily describe, but also non-intuitive patterns hidden in numerical image data. This is why I think CNNs have significant potential. They can handle they can handle types of information that are difficult for humans to directly perceive. Now, I would like to talk about my experience at Wildlife Workshop. The first place we visited during the workshop was the Yanggu Musk Deer and Mountain Goat Center. There, I learned that one of their major interests was to analyze camera trap images of musk deer and mountain goats. Spe- Specifically, they wanted to determine which images showed the same individual and to understand the habitat range of each animal. The problem was that there were too many images, but not enough people to analyze them. In this situation, I thought CNN technology could be useful as a practical support tool. I think it could reduce the number of candidate images that experts need to review. Furthermore, since CNNs may be able to detect non-intuitive patterns in images, I thought they might eventually provide additional evidence for individual identification. To help you understand this idea more clear, to help you understand this idea more clearly, I prepared a simple prototype. This is my prototype. This prototype takes an image of the overall cat as input, then using CNN, it extracts features from the images and compare them with images stored in database. Based on this comparison, the program estimates the breed of the overall cat in input image. By the, by the way, I personally prefer cat stock, so I usually test it with cat imaging. We will use this image. Now the result is led. Uh, as you can see, the program shows the top five most similar images. This is designed to help users make judgments. Another important point is that after a program makes a prediction, an expert can provide feedback. The program can then use this expert judgment for further learning. In actual development, I think this feedback process would be extremely important. Expert participation would be necessary, especially if this kind of system were applied to real wildlife data. So, to summarize, I think it is a useful tool that can support experts by reducing the workload and by suggesting useful candidate images for comparison. Thank you for listening.